All right, so yesterday we talked about exponential growth. Today we're going to talk about exponential decay. And here's our model. This is what we're going to use for pretty much all of our exponential decay models. Y equals A times quantity 1 minus R raised to the t power, where A is the initial amount, just like with the growth. R, of course, is the rate. Now, the thing about the rate, remember, make sure to make it a decimal. And T is time. Now, time can be in whatever it says. It can vary. All right, it could be years, it could be seconds, it could be minutes, it could be eons. However long an eon is, that's more of a relative thing. Anyways, the quantity 1 minus R is called the decay factor. Decay factor. So it's a formula. What we're going to do now is a bunch of word problems. It's pretty much straight up plug it in, chug it out. All right, but occasionally they want you to find a model, like in this first example here. You buy a new car for $24K. The value of Y, or the value Y of the car decreases by 16% each year. Cars are not a good investment. Write an exponential decay model for the value of the car. So Y equals the initial amount. The initial amount is $24,000 times 1 minus, and the percent is 0.16. Remember, make the rate a decimal. Raised to the t power. Now we're raising it to the t power because remember, we're making a model. This is the model. Even though they want it for 2 years, first we're making the model. Anyways, this decay factor. Remember, 1 minus R is called the decay factor. I would rather you write it as Y equals 24,000 times, and this is going to be 0.84 raised to the t power. All right. I don't think I'm going to get too fussy about either one, but this is a better way to write it. Now, my question to you, can you multiply 24,000 times 0.84? No, you cannot. Anyway, so now let's find out what our car is worth after 2 years. 24,000 times 0.84 to the second power. Plug that straight in your calculator. I'm going to use mine that's not on the computer because it's easier to push the buttons for me. Times 0.84 raised to the 2. Hopefully you should come up with approximately $16,934.4. Actually, this isn't even approximate, I don't think. I think this is the straight up. Yep, that's the value of this car, $16,934. Not a good investment. 2 years, you're losing a lot of money. Graph the model on your calculator and sketch below. This one I will use my calculator here so we can look at it. So we're going to graph this 24,000. Oops. See, this is why I hate this calculator. Never does what I tell it to. 24,000 times 0.84 raised to, now, even though it's t power, we're going to raise it, of course, to the x power. Now, if you just have it in your standard window, surprise, surprise, it doesn't show up. Let's think about why. Our x value, what does x represent here? And x here is t, so this is negative 10 is fine. We're not going to go back in time 10 years. However, we might want to know what this car is worth in, let's go to 15 years. We'll scale it by 1. The y minimum value, hopefully we'll never have to pay money in order to have this car. Well, I suppose you do in a sense, and registration, gas, everything else. But ignoring that, just the value of the car, we'll keep it at negative 10, but we're not really concerned with that. Y maximum, well, what's the most amount that this car is going to be worth? Well, since this car is decaying, the initial amount is the most amount it will ever be, 24,000. So maybe I should go 25,000. We'll just go with 24,000. Press graph, and There it is. You can see it falls pretty fast. So, just a quick sketch of what this looks like. This looks like this. Now, because the price gets lower and lower and lower, but we'll never have to pay money. We're taking 16% off each previous value. This actually approaches an asymptote. The asymptote is y is equal to 0. The window that we're using here, we're going -10 to 15 by, and we went -10 to 24,000. That was our window. So it says use the graph to estimate when the car will have a value of $12,000. When is it worth half its value? Now we could just plug in 12,000 in for y and solve it, but it says use the graph to estimate. So we're going to go back into our y equals, and one of our y's is the function. Y2 is going to be the value. All right, 12,000 is a y value. Press graph, and we can see where this line goes and intercepts this curve. So, does it make sense that the intersection point is going to be our answer? So let's find our intersection point. Number 5. Now, your calculator is pretty awesome. Just press enter. Come on, enter. Enter, enter, enter 3 times. And you should get 3.98 comma 12,000. So what does that point of intersection mean? Well, that point of intersection means it's going to take approximately 4 years. In 4 years, our car is going to be half its value. I'm going to tell you what, that is a bummer. Now, is that true for all cars? We'll talk more about this tomorrow. No, there's some cars that appreciate classic muscle cars and whatnot, but generally, that 98 Civic, that's not going to increase. All right, let's go to page 2. There are 40,000 homes in your city each year. 10% of the homes are expected to disconnect from septic. If you're not sure what septic is, ask me tomorrow and we'll talk all about septic. Some of you know. Those of you who don't, you might not like what septic is. Glad you have sewer system. Right, exponential decay model. So, our model, y equals the initial amount, 40,000, times 1 minus, what's happening? Each year, 10% are disconnecting from septic. So we're losing 10% to the t power. So this is, remember, our model, what I would prefer it as is 40,000 times 0.9 to the t power. Remember, we can't multiply these because while 0.9 has got an exponent of t, 40,000 has got an exponent of 1. In order to multiply, you need the same exponents. Anyway, so here's our model here. And then they want us after 5 years. Again, I'm going to use my offline calculator to figure out that y equals 40,000 times 0.9 to the 5th power. 4123 times 0.9 to the 5th. There's going to be approximately 23,619 homes still on septic. Now, for those of you who got your calculator, you probably got a 0.6, right? We talked about that. For our final answer, 0.6 houses, well, 0.6 houses could conceivably be on septic. Somebody could be having their house done at the moment. So 23,619.6. Because it's a house, we can be more than halfway done. Now, if these were puppies, that's sad and disturbing a little bit. Sketch a graph. So let's get our calculator out. Clear out our other stuff. I'm going to pause it for you. Rather than torture you, have me press these crazy buttons, I just put it in right away. Now, again, we're going to have to think about our window. Let's go back. I didn't like our X window the last graph. So I'm going to change this to -1. I like to see the y-axis, but I don't need to see all of that negative axis. So I'm going to go from -1 to 15 because that's 15 years of what's happening here, scale of 1. And we're going from -10. That one's fine. Since this is so big, that's not really going to matter. But what is the most amount that this could possibly be? The most amount it could possibly be, of course, is right now there's 40,000 homes on septic, but they're getting away from septic tanks. So then press graph. And there's our graph. It goes down pretty quickly, and then it starts to level out a little bit. So it goes down like this. And again, our window's -1 to 15 by -10 to 40,000. All right, so the last example here, the last example here, your car is now worth $5,000. You bought it 6 years ago and you expected it to depreciate by 15% each year. That would be wonderful if it was only $15. How much did you buy the car for originally? All right, this time we're trying to find the original amount. Our car right now is worth $5,000. So 5,000 equals the initial amount times, and we knew it was going to depreciate. Excuse me, not 1. 1 minus, we're going to depreciate by 15% each year, and that was 6 years ago. So this is a straight up solving problem. So you have 5,000 equals a times 0.85 to the 6th power. What is 0.85 to the 6th power? 0.5 to the 6th power is a big gross number. So I'm going to pull up my calculator for you. And what we're actually going to do is we're going to solve this. Remember, try not to round until the very end. So we're going to take 5,000 divided by, and parentheses are always a good idea here, 0.85 raised to the 6th power. Right? We're dividing here by 0.85 to the 6th on both sides. And you should get approximately, A is approximately $13,257.34. So that's what we bought our car for originally. All right, exponential decay. It's kind of nice. There's only one formula for it, and you just got to decide is if the situation describing a decrease, it's exponential decay. We'll do some problems tomorrow.